Hello, hello. Welcome back to C Studio AI channel, Making Next Gadget. I'm Jennie, the product marketing at C Studio. And sitting next to me is Ethan.
Hi, I'm Ethan, product manager. Good to see you again.
Yeah, we're really excited to see you guys here. So during several weeks, we've been going through so many live stream episodes talking about the AI hardwares covering from smart sensors, IoT devices, and more intelligent AI agents. So these are like the innovative projects that we've been working with lately during this year. And we are eager to bring more creative gadgets and showcasing possibilities that we've been discovering in the practical application scenarios. Then today, here we come. So Ethan, what exactly the smart gadget would bring to our audience today?
I think that's the answer is already on desktop, right?
Yeah.
So this is a product we have mentioned in the, I think it was last month.
Yeah, maybe.
The new member of our RISC family, reCamera. So today we are not just bringing you one reCamera sample, but the whole reCamera family. So from here to back there.
Yeah, there's
so there's so many things that we could introduce to you today. So let's go ahead.
Yeah, right. And besides all the hardcore big release, we also bring the same old exciting traditions for you guys. You know what it is, right? So that is the lucky draws. There will be 2 round lucky draws, and we will randomly choose 5 audience in each round. So everyone draw in the chat box, say hi or emoji or anything showing out here. Then we'll take the first 5 person by taking a screenshot on my phone, so you guys can see the results in real time. And we'll provide each one a coupon to cover the full price for one reCamera 64GB version. So each winner can reach out to our community manager, Ray, providing an email address, and then you can get the coupon code. But if you miss the lucky draws, don't worry. We also have a special coupon for you today. So like during this...
You could pay for $5 for a 50% off coupon.
Yes.
That's an early bird price for a camera. So that's kind of like placing a pre-order, but it's limited to 100.
Yeah. It's
right?
only valid during this live stream, and it's open for 100 spots. So just keep in mind, if you want to get the reCamera earlier, this could be the best chance, right?
Yeah, that's surely the best chance.
Yeah. Is that clear? So hopefully everyone gets it. You can also check out the Apple box on the screen. There should be a hint about today's benefit. All right. Yeah.
So I think
so now let's get back to the mainstream, okay?
Yeah.
Our reCamera.
I think there's we couldn't wait to talk about more about what is a reCamera, why we make a reCamera.
Yeah.
So just in short, reCamera is a combination of processor and camera sensors. So just imagine we are putting a small computer and a sensor into this small box, and this provides you as a, kind of like a robot brain or something, a small computer that could just directly process the image data or other data and complete some control tasks by itself.
Right.
Yeah.
And actually, there's already lots of community voice talking about like their preference. They're saying like reCamera can provide such powerful AI capability within this tiny little thing. So this is like smallest as 40 plus 40 plus 3.
Yeah. With the case, it has 40 plus 40 millimeter width and height. So it's a small square here, and
also, I think based on our experience of many like IoT devices or the AI modules, we've already have many IP camera choices in the market to handle this kind of computer vision task, right?
Yeah. So today, that's something about why we make a reCamera.
Right.
So there's already a lot of cameras in the market. So today we also bring one here. So this is a formal IP camera on the market and for consumer, for monitoring usage. But they are all closed source. They are not used for you to play with, indeed. So indeed, the concept of reCamera is not that advanced. It's already on the market. So let's take a deep look into this camera. So after we taking it apart, we could see that within here is the control board of this IP camera. And underneath this big heatsink is the processor. So this is also a kind of processor plus camera sensor combination. So this processor provided with some edge AI acceleration ability to do like person detection, person counting, and then send back data to the monitoring system. So okay.
So this kind of IP cameras is like a closed source for the hardware. And even though you have the choices like the open source platform such as the Open IPC, this kind of platform.
That's an organization committed to build an open IP camera firmware for you to use.
Yeah.
But even if you are using this kind of firmware, you are still rely on the hardware. It's kind of like a hacker work indeed. From my own experience, you have to hack into some existing IP camera and see what the model of their processor is, and try to flash the new firmware into it. So this is the hardware. So in short, hardware design is still closed. So you only use the interfaces the supplier assume you should use. You don't have the freedom to customize it. Yeah.
I think that's why one reason that we win.
Yeah. That's one of the very important reasons that we want to make the camera. And also, there are surely other open source choices like some AI camera developer kits like OpenMV. I think there was previous a very hot processor called K210. There is also a lot of AI camera dev kits based on this chip, but they
all seem like easy to be developed or customized. So do you know what's the difference between these and the reCamera?
But the main difference is just like they are making for you to develop. So it's it has some distance between a formal product or something you could directly use. It's still very draft. It's kind of like draft. So today we want to combine the benefits of the two things above. So let's show how we make our reCamera.
Yes. All right. So now I think we got the basic idea about what is a reCamera. So for our audience, it's time for us to explore what's the components inside of it, right? So how's the system architecture looks like?
The system architecture, indeed, we have tear it into 3 parts. So let's show it with the real things here. So the camera, this one above it is the formal one with the case. Well, if we take out the front and back case, the bare ones look like this. So we have it taken into 3 parts. So the front, you could take it off, is the sensor board. So
this is the sensor board?
The sensor board carries the camera sensor and other like lights or microphone, speaker, this kind of thing. And the back one is the baseboard, called baseboard. So this one is having some the connector features. So let me zoom in. So you can see that the Type-C connector, SD card, and Ethernet connector. And while the left along is the core. So we call it core board or the mainframe with it. So this one carries the SoC, the processor, the onboard storage, the wireless module. So every customization and DIY or the project goes from this one. And you replace the sensor board, replace the baseboard to change it into any form, any sensor you want to use.
There's lots of expansion possibilities for this. So we'll mention this later. And about the onboard, the memory or the can you show us more about this part?
Sure. So let's take a look at here. So we have already open sourced part of our project on GitHub. So let's see here. you could see here we have already open sourced our project at this open source hardware, the camera series,
yes.
and we have already done a lot of work in it. If you are interested, please give us a star.
Thank you.
Check this photo here. This is more clear about what's inside. So the middle one is the core board. This is core board, and the right one sensor board, the left one base board. You could see on this core board there's three main chips. So that's what we have done with core board. And we have put the processor, we have put the Wi-Fi module, we have put the onboard storage, all on this, and also an antenna, onboard antenna, but it's not soldered on this picture.
Okay.
Yeah, but we could show you from here. So there's
here's it, right?
Yeah, here is also an onboard antenna. Yeah. So this is a brief view of what we have on this core board, but I think before we go deep into everything else, we should first introduce what processor is, right?
Right.
Yeah. So the processor is not so familiar with everyone. So this is not an ESP, the MCU. This is not a Raspberry Pi. So what it is called the SG2002. 2002. Yeah, ST2002. ST2002 is a SoC, not MCU. So what's the main difference? The SoC runs a Linux, while the MCU always the traditional design of MCU. The way to play with MCU is writing while loop. While the SoC is a Linux system, so you could write multi-thread, more flexible design, or play with.
So for the multi-threading parts, it seems like the system on chip solution will have more power consumption, right?
Yeah, surely it will. The power always comes with some costs, and nothing have all the benefits. And according to our test, indeed, the power consumption is not a big issue. So like what we have here, so you could see we have a handheld battery module. Down there is a 4,000 milliampere hour. So it could last for 4 hours according to our current test. And you could surely try to lower the power consumption by like algorithm design or logical design. So there's a lot of way to solve the power consumption issue.
Yeah, that's good to know. Yeah, and also for the Wi-Fi module, the wireless module part, what did we do for the reCamera?
Yeah, that's a good part. So let's check here. So you could see that we have the Wi-Fi module on board, and also this antenna we have mentioned. That antenna was a really big difficulty we have conquered during our
the hardware design.
Yeah, hardware design, because we want to provide the best onboard antenna performance for you to use. Because tuning the antenna is not always a good, easy task. So you have, if you don't have a professional experience or some professional lab, it's not easy to tuning this antenna.
Yeah.
But surely, even the best antenna on board can't outperform the external one. So, well, on this board, we didn't see the apex connector, but in the one we are going to ship out, there was also a choice of apex connector on board. So you could choose to use the external antenna.
That's as a second option, right?
Yeah, that's just a kind of choice. You know, extra volume gives you the extra performance, while this neat volume, this neat design gives you a really easy to use, ready to use solution.
Yeah.
So according to our current test, this antenna could already have a good performance. So under 2.4 gigahertz, you could have about 5 meter, while if it goes to 5 gigahertz, it will could go longer, like about 10 or even further, but we haven't finished the test, so.
Wow,
yeah.
10 meters away is really enough. And
yeah.
what about the heatsink for this frame? How do you design for that?
Okay, so let's switch to the some. Okay, so as you can see here, so the song is also shipped with this middle frame. This middle frame is a really big one. It's because this SoC comes with more power consumption and heat dispensation.
Yes, yes.
We need a better heat dispensation to keep the temperature down. And so we had made such a big one for control the heat, control temperature. According to our current test, this could let you to use around, I think, 60 degree in
below that, right?
Yeah, below 60 degree, and for a long-term usage at kind of like a full running. Yeah, but yeah, this is a rough estimation. We haven't finished a test, but also this frame provides you with some other benefits. So you can see there's a
the rubber ring.
Yeah, there's a round of rubber ring here, and also let's take this off. Yeah. So also everything here. So this one provides you with the waterproof and dustproof ability. So if you could screw the front case and back case correctly with some suitable force, it could give you waterproof ability, like around IP54, I think maybe, but we are still finishing, so we will update it later in our community. Yeah, so
that's kind of reliable for like the full system for the AI camera, right?
Yeah. So we're making this for you to design the case and hardware more easily.
Yeah. It seems like it's already used full system for the developers compared to those bare developing boards. So combined with these peripherals and the frame design, so does that mean the full system can now really be easily developed and played to be further integrated or customized?
No. Today the problem we want to solve is that a ready-to-use product doesn't equal with a maker product. So this one have unleashed both hardware possibility and software possibility. So the software part we could left for the later on in this live stream. Well, the hardware part we could give you, but the hardware possibility have all been unleashed through this B2B board-to-board connectors in this frame. So, talk is cheap. Well, in short, talk is cheap. We could show you all the other board we have designed in these short weeks, and you will see the possibilities. Well, after talking about so much things, before we dive into more about these boards, maybe we could have a lucky draw.
The first round?
The first round?
Yeah. I think it's time to do it. We really appreciate everyone's love, support, and passion about our reCamera. So we'll give out 5 pieces this round to our friends. As we mentioned at the beginning, everyone in this live stream can show up in the chat box. You can do it now, say hi or everything, like I love reCamera keep up, this kind of thing. So I'll take a screenshot here on my phone. You can check out the result in real time, and we'll take the top 5% and give you guys the coupon. So yeah, now let's do it.
Okay, so everyone, just do the lucky draw.
Give me a sec.
Okay, let me switch to the.
Yeah.
Okay.
Let's do it here. Yeah, right now I'll count down to 5 numbers. Okay, so 5, 4, 3, 2,
2,
1.
Okay, screenshot.
Here we go.
Okay, so let's check who is the lucky one in the front.
Can you see it?
That's kind of too white, but
I'll just spell the name. I'm so sorry if I pronounce the name not correct. So the first one is the 22V10.
Ah, 22.
And the second one is Eric Jobbington. The third one is Christopher G. Waldeny. I'm so sorry. And the fourth is the same with the first one, the 22V10. So this is not.
We just skip it.
Yeah,
we can't have too many gifts.
So the first one is Derek Jacoby, and the fifth one is Masilo Vera. Hopefully I pronounce it right.
No worry. We will have our teammates will contact you according to your name in this YouTube channel, and you could send the other info that necessary. That we will ship the lucky draw.
Okay.
The camera for you.
So the other friends who did not be selected, no worries. We also have a second round today. And also you can apply to our alpha test registration. The link should be in the chat box, so you can also check it out. And we'll send out samples to some selected users among these appliers. And everyone drawn in this registration will also receive a 10% off coupon to purchase the reCamera.
Yeah, just see upper link. So. Okay, right. So get back to our topic. So before we goes more deeply in, so let me have a brief look of these comments.
Yeah, so, we want to hear what the voice for among our community, right?
I see that someone needs a gimbal units. Oh, no worry, we will talk about this gimbal just later. This is an open source project, so you could surely do it by yourself.
Yeah.
And where's the purchase link? Oh, can anyone send the purchase link again in the channel? And Linux can stream better, I'm guessing. Yeah, the Linux is always outperforms other system in this part.
Right.
And can the turn run AI for target acquisition? Surely it has OneTop's AI performance. I think we just missed that. OneTop's is very rough description. Well, I think if you want to say it more exactly, then you could run some mainstream AI model like a MobileNet, like some YOLO model, or smoothly like 50 or even 60 frame per second on this device according to your design.
Yeah.
And
so it can also handle like 1 or 2 streams for one camera, right?
Pardon?
The stream, I mean the video streams, how many video streams we can connect with?
The video stream, indeed, there's no limitation. No limitation. It's an RTSP stream service that we could see it later. You could just open up a lot, and also you could customize with the software we provide. And so let me check any other. So do I need the thermal paste? The thermal paste will go with the camera, no worry. And the other. Okay, I think that's enough for this part. I think we need to go into the next part.
The expansion possibilities. I think we can check out how many expansion boards that our application developers have been built during these 2 weeks.
Yeah. So let's go back to our open source project. So here we have the core board information partly released here. We will release the other parts after our design was finished or fixed. So you can see we have already opened the B2B connector pinout definition. So according to this definition, you could already do a lot of things.
Right.
So let's first still talk about the sensor board part. So the sensor board, just to see in this video, during these days we have done about 3 different sensor board design. So one is the original OV5647. That's the same model as the original Pi camera version 1. Yeah, so
I guess everyone's familiar with that, right?
Yeah, that's a very classic one. While also we have other 2 sensors available for you to use. So let's get back to our here. The OV sensor will be the default sensor will ship with reCamera to you for use in the first batch, while the other 2 sensors may come online later. But we have already open sourced our design file here, so if you are interested, please let us know. And this other 2 sensors are, one is for better image quality, and well, another is for global shutter. Yeah. So on this, let me introduce the first sensor board here. So you can see that the first sensor board have already almost all the features designed on board. So from the sensor, from the mic, from the speaker connector, from the LED lights and status lights. So I think all the necessary functions has already been used here, and you could start your further design from this one. The KiCad project file has already been open source in the GitHub. You can check it there.
Yeah.
And we also attached the sensor performance here if you are interested. And there is a short summary of what features on this board. And the other 2, that's the most important part. So using camera sensor or design your custom image sensor is not always a not always an easy thing.
Okay.
Yeah. So using image sensor both need you to have some knowledge about the hardware and also the software. So left alone the software part later. So let's just see the hardware. So today first we solve hardware and later we talk about software.
Yeah, exactly.
So there are these 2 boards indeed are the 2 classic way to using some existing CMOS sensors. So for us, it's not always realistic to customize some camera sensor, especially for individuals.
Yes.
It's not realistic. You have to pay for a big customized fee if you want one customized sensor. So most of our choice is use the existing one. Well, these 2 sensors are all existing ones we pick up randomly from the market. So for this one, IM335, this is a raw camera sensor. So it has only the lens module and the CMOS sensor combined on this small FPC board. And there's an FPC connector connect to the board, and afterwards you connect the MIPI links rightly, give it the proper voltage it needs, connect some other I2C and I2C lanes and some enable lanes, and then it's finished. Then it's finished. So, well, this is still too complicated. Indeed, it's still too complicated.
Well, for me, it is really hard.
yeah. There's still some surrounding things you need to design. But there's another way, using the whole existing camera sensor. So for this one, as this global shutter sensor, we picked the existing camera sensor board from the market. It has all the necessary peripheral design finished, and you just need to design a connector board. So like here, so the B2B board just need to connect the MIPI lanes and other lanes correctly to the corresponding one.
Yeah,
and
that's more clear.
Yeah, then that's finished.
No.
All the things you need to do is solder this two connector, and then since it's finished,
that's
finished. Yeah, that's the really easy one.
Yeah.
Yeah, but well, for this one, you may have to sacrifice some spaces or design that it may not look so pretty. So you can see that we have our this one, and we have put here is
yeah, we can take it apart to let you know how the sensor looks like.
Yeah, you could see this one, the camera industrial, using a global shutter sensor. So you could see that the sensor board goes outside of the cases. Then that's the cost of using this kind of sensor.
Okay.
But it was really easy to design. That's really easy to design. Yep.
Okay.
Well, so that's all about the sensor part. So if you are interested in more, so let's kind of see. Anyone has some questions about this part?
If you have any ideas about what kind of sensor modules you want to choose based on this reference design, you can also pop it up on the comment and let us know. We can show more possibilities for you, right?
Oh, someone is thinking Frank is on the remote control of that gimbal. No one is behind this too. No one is behind this too. I will show you how they are controlled later. A B2B connector, yeah, board-to-board connector, yeah. Trouble with AI zoom camera. That's okay. SenseCraft support. Well, SenseCraft support was something that will not be mentioned in today's live stream. We will do it later.
Yeah, we'll consider about that later.
Yeah. Can do LiDAR scans if you can find some proper LiDAR sensors. Indeed, it could be integrated into it. Indeed, we are already doing this. So the sensor board is not limited to carrying camera sensors. Also, the the LiDAR sensors, radar sensors, even the TOF sensors, they are also kind of sensors that could be processed. Okay. So we are also looking for these existing sensors, and if stay tuned in the community, and we will have some surprise for you if we have some progress.
Yeah, just stay tuned.
And also we could discuss there about what we have found already. Okay. Yeah. Okay, so I think this is about this is more. This is all about the sensor part. So let's go to the connector, the baseboard part.
Okay.
Baseboard part.
That's the most exciting part that we want to show you guys, because we have so many possibilities and we want to hear more ideas from you to what kind of interfaces you want to use based on this reCamera design.
Yes, and you could see here we have bring you four baseboards today. Yeah. The baseboard will be much easier to design than the sensor board, because on the sensor board you still have to think about which kind of camera sensor I could achieve and how to route that MIPI lanes. Yeah. And there's still a bit difficulty there, but well, for the baseboard, that was really easy. Every signal was easy to design. So the default one we have here have all the basic function in it.
Yeah, we show it at the beginning, right?
Yeah, the Type-C connector, the SD card slot, the Ethernet connector, and the UART here. Okay. And we have quickly redesigned a similar one with a vertical Type-C connector. Oh. Yeah. So you could, and and indeed that was just being finished in one day. Just one day.
Really quick.
Because all the project is already there. You just need to replace the Type-C connector layout to this vertical one and then finish. Okay. Send it out to sample production, get it back, solder it on and down, and down. So,
so that's for our effort, application engineers' effort. You can also do it.
Yeah, you can also do it. Well, I think someone should have some questions about Ethernet part, as I have mentioned Ethernet connector, but this is not a standard one.
Okay.
This is not a standard one. So
in the comments, there's someone say the vertical USB is really nice work.
Yeah, the vertical USB, the baseboard. Why we have to customize the baseboard is because everyone has its own usage scenario.
Yeah.
So why the default one is horizontal is because on the back case of reCamera, there is magnetic in it. So let me see if this could. Yeah.
Oh.
Yeah, there's a magnetic. So indeed, this one could be attached to any surface with magnetic attraction you want. So we designed a horizontal one, but there surely will be someone need the vertical one because they want to route the lines more perfect. So, where is
you just choose what you want.
Yeah, they hit it here. So the vertical connector, just replace one thing and you get it.
Yeah.
And forget. So back to the problem. So why this is Ethernet connector? So you have to use this line and this wire, this Ethernet external line for the wireless connection. Well, this wire will be shipped with reCamera to you in every batches. This is a default for this board. Well, because on this board there's no place to place a full RJ45 connector on it, so we have to use this one. Okay. But I think the Ethernet is always not enough because you have to route two lanes, one for power, one for data.
Oh, right.
And afterwards, we do the PoE. Afterwards, as I see someone's already saying it, we have the PoE ready here.
Yeah.
So let's take it apart. So we have already done the PoE one and it works very well. We utilizing, this is the version 0.1 and we will have formal one. We'll put in this PoE, the PoE, the PoE not as a separate module, but putting it all on the board and as a whole board. Someone is asking, is this the Ethernet cable standard connector? Yeah, it's a standard one.
Okay, I take out the PoE.
Okay.
Right here.
Yeah, so you can see it's already in it, and you just connect one lane, power, data, all ready to use. Okay. Yeah. So this is a PoE one, and we also And after the PoE, I think it's time for our today's main character. This one before gyro. So we have put the gyro sensor and CAN communication module on this baseboard.
Okay.
That's the baseboard already get in used. Oh, sorry, I forgot to change back to this screen. So you can see we have put for before we have the gyro sensor, TTL to CAN. Well, this one will be changed to SPI to CAN later. This one is in the gimbal. This one is in the gimbal. So the gimbal has this one attached, so to do the control.
Okay.
Yeah. And this one will be a bit more complicated. One CAN port, one gyroscope sensor, one UART port. So this is all kinds of the baseboard we have designed in very short interval, and I think there's a lot more could be done, right? So, and maybe some of the board doesn't have the KiCad project ready in this repo, but no worry, we will update later when we have finished some tests and modification. So give us a star and watch the stay watched with this repo.
Yeah, we also welcome everyone to like contribute to this reCamera community. So share your ideas about what the expansion boards you want to build, and we can also help you to build that.
Yeah, you could have two choices: build it by yourself. We are glad to offer you help in the community, or you could just directly contribute one directly to this. And today we will just skip this part, but I have to mention we have some co-create programs. So if you have some products want to build upon the camera hardware, please tell us. We could help with you with mass production and sample build up. That's something we have already done for a very long time. That's our tradition with the community.
Yeah, that's amazing.
Okay. So I think many of you can't wait to know how the software and the Gimbal projects is, but
before that, wait a second.
Take a break.
We can
make
take a break.
A second round of lucky draw.
Yeah. So in case anyone just come in and not familiar with today's benefit rules, so for this round, we'll also randomly select 5 person to give out the coupon, which equals to the full price for the reCamera 2002W 64 gigabits version, right? So I'll take the screenshot on my phone here. So everyone, now you can also say hi or say everything in the chat box. I'll choose the top 5% on the screenshot.
Or you could just send what other feature you want.
Yeah. Say anything you want in the chat box.
Okay.
All right, let me come back again. So it will be the real time.
So let's do some. Okay, let's wait for some extra seconds. Wait for you to get ready. And let's start the second round.
Yeah, let's count down to 5,
4, 3, 2, 1. Screenshot. Okay. So let's check.
So
who is here?
The first one is.
Oh, it's half in the.
It's
Beer Bread Orange. Anyone here?
Yeah.
Congratulations, you got one. And
second one is Alejandro Chudilo.
Anyone here?
Sorry for my bad pronunciation.
You get one.
Yeah.
You get one.
And the third one is
Domingo
de Silva.
Domingo Silva. Yeah.
You
got one. And idle user.
Who
is idle user? Who is idle here? Okay.
And the fifth is the same.
Oh yeah, and Chujilo, you already got one, so we skip you. And the last one, Brumi. Congratulations, you also got one.
Congratulations to these 5 person, and you can reach out to our community manager Ray to give your email address, and we'll send the coupon code to you shortly. Okay.
No worry, we will type all these 10 winner's name in here or in the community. We will try to find you. You can also try to find us. Yeah.
And don't forget, there's another choice. We have the special offer for today's live stream. You can purchase a 50% off coupon with only $5 through our QR code.
Just take it as a $5 pre-order. If you're really interested to get one, $5 for 50% discount. So how much will the discount be? Just keep it later. If you don't make up mind to place the order, no worry. We will show you the price later.
Ethan, can you show up the QR code for the guys who can check out the link?
Sorry, I think I forgot it for a really long time. So
that's
where
okay.
it is?
That's okay.
Okay.
You can scan the QR code here to check out the 50% off coupon link. All right.
This one?
Yeah.
No, this one.
This one, right?
This one. So here you can scan the QR code to place the order.
So you can purchase this coupon first, and feel free to use it when we release the reCamera officially on the Seed Bazaar. So just stay tuned for our product release. Okay?
Yeah. And someone is asking whether we could use two 50% coupons at the same time. Well,
no.
well, indeed,
I think it's one person can only purchase one coupon.
Yeah,
right?
and also this coupon only applies to one unit. You can't just play or 10 units order and do the 50% card discount. Well, that was really insane. So please.
Bad news for you, but
I knew you wanted, but sorry, I can't afford this.
Okay.
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 So let's get back to the topic.
Yeah, we have talked about so many things about the hardware.
Yeah, and just 1 second, I think we just forgot to do some quick review about the comments. And one thing, this is suitable for low latency application. Well, the low latency is not an issue at camera side. It's indeed about how you transmit the data. So if you want to do low latency, I will recommend you to use Wi connection. Well, if the Wi connection is not available in your scenario, there will be a choice to use other wireless connection. I forgot this. Okay, that's back to. No. We can't just forget this part. So back to the core board. So at here, we have indeed 2 core board version. One is the wireless one is the not wireless. So
I'm also curious about that.
yeah. So in the features, you could see, well, for the wireless module attached, you have the Wi-Fi BLE, onboard antenna, and the external antenna connector all available. But what if you choose, if I want to use other communication wireless module, like Wi-Fi Hello, like LoRa? So that's why there is existing one without W. So in this one, when this wireless module is not attached, all these pins will be released to the bottom B2B connector, which means you could design or attach the other wireless module you want to connect on the baseboard. So the baseboard is not even just a limitation on the connector, but also the wireless module.
Oh, okay. That's a big update.
Okay, someone is asking for making compatible one with Xiao. Okay, I will pass this requirement to our product manager. Yeah. Okay, and also someone, how about thermal vision and ToF sensor? Yeah, that's 2 things we are already working on. If you have any idea or any existing module you want to directly use, tell us. We are just picking the right thermal vision and ToF sensor onto the sensor board family. And also, baseboard is really flexible. What about B2B to Xiao? Well, we don't have the core board version for ESP, but you could hope for it. If you really want, just tell us in community, sign up for that requirement. And if you really want, indeed, this design is open source, and you could attach Xiao module onto it directly with 2 B2B board, and you got 1 Xiao.
Yeah, we also
core board.
We also hope to see that.
Yeah, we also see that. So someone is asking for coded file on BLE. Well, the file, I don't fully get this part, but the file connection and BLE are not conflicted. They are 2 separate ones. You got 100 mega, 100 megabyte Ethernet connection, and Ethernet. And BLE takes the UART connector. So when you choose to use in the core board without wireless module, extra UART connector will be released to baseboard. Yeah. Okay. Okay. Let's get back to the software part, right?
Yeah. It's time to do it.
Let's get back to software part. So I think it's time to get back to this project.
So I think we should show our audience how to use the reCamera, like in the real scenarios, right?
Yeah, indeed. Here we have two things ready for use. One is a basic reCamera operating system. So I have to clarify, this is a Linux system, but not a standard one.
Okay.
Someone may not be familiar with this kind of system. It's a build-root system, not a full Debian, not a full Arch Linux, not someone with the suitable apt, Pacman, or anything that you could think about the package management system. So you can't just type in apt install. So it will be a different, like a big difference than using it as a Raspberry Pi. So if you are familiar with Raspberry Pi, this one will be a bit different. Well, so this is a build-root system. How to say the difference? So the build-root system gives you more flexibility to build it up on some resources limited chip. Okay. So like reCamera, this chip only have 256 megabytes RAM, so it's really limited. While the formal system takes some bigger place, but they are easy to use.
Like for the SBC, this kind of devices, right?
Yeah. So just like so if we make a comparison, I think the full operating system will look like a hotel. You could directly walk in and live in. While the reCamera OS, this kind of build-root OS, is like a raw building.
Empty room.
The empty room without any decoration. Okay. You could build it up flexible with anything you want, but it will require some knowledge. But no worry. We have the basic system already in here. So we haven't finished the wiki build up, the README build up on this repository. So okay. you may feel a bit fuzzy when you go through this one. But let me talk about what features we have already built in it. We have already built the basic over-the-air update feature in it, so it will be easier to develop. Okay. You could just send new firmware to it remotely and it do the update, so it will be really easy. And also, we have built up a basic web page. So you can see here, reCamera web. We haven't finished putting the code here, but I could directly show you. So, okay, let's make a refresh. So this is a live view of the reCamera Pocket. So hey guys, back here.
Back to here. So you can see from the reCamera to see our team members.
Yeah, back there. So the wireless signal is not really good here because there's too many wireless things in room. And so this is the and this web page provides you with some basic features, like you could make basic security changes, like change the username, password, SSH key, and configure the network connection. And there's also a live terminal here. Live terminal. Where is the live terminal? Come out. Okay. I think that's for the back signal here. Too many things. We are making a live stream. There are too many wireless module here, so it got terminated. But there is a wireless. There is already a terminal built-in web page, and you could directly access it. And also, we just said there is a system update feature already built in. You could update through the channel of Seed Official, or also from the customized. Okay, I think the Pocket is not going to respond to me for this round. Well, and also reboot, shut down some basic check, and I think it goes offline. Where is it? No worry. It doesn't matter, but you could see already where the web page feature already have. And we will open source. We will also open source this web page code for you if you want to add more features about control your devices. I think like control your gimbal, control the robot arm. There will always need to need to have an interfaces, this web page could be your best friend.
Okay. So this is kind of like the how to access the reCamera. So it's very easy to get hands on that. What about the visual development part? Like should we code writing for the vision pipeline?
Yeah, this is this is a place haven't mentioned how to develop it. This is how to interact it.
Okay.
But how to develop it? Okay, everyone, time to get to the camera gimbal. So finally. So how do we control the camera gimbal?
You can see it rotating
randomly. It's rotating randomly. Or in this live stream, and the same for the arm back there, but we are not going to deal with him. We are going to deal with this one. So we have made a customized NodeRed module, and we migrated it into it. So we migrate both Node.js and NodeRed onto this reCamera platform. So and we build up some good ready-to-use node here. So the main two node is camera node and model node. That's all you will need to deal with the AI performance part. So before we goes into the AI performance developments, let's clarify how does it work.
What's the components inside of the pipeline?
So currently, it's not using the AI. It's just conducting this line. Okay. So it starts program and generates the random number and send it through a gimbal control script, and then it will turn. And then loop. So after I disable this node, so let me see, disable, done, and redeploy, it will stop.
Do you stop?
Yeah, it stopped.
Okay.
No, it's not working.
Okay.
It's not rotating anymore. Well, if after I re-enable it, down, deploy, I think it should goes back to random rotating again. Yeah, you see, it's going to looking around again.
So you see, it's not Frank controlling that.
Yeah, no, Frank is playing with his phone. Frank is playing with his phone. No one is controlling. Yeah. So so this is the control script. So this is really straightforward. Although we have using some customized function, but this is have already show how you could this is combination development of both row code and the flow control.
Okay.
So we have some teammates writing the gimbal control script in C, and it compiled to this test M script. Oh, no. Okay. And then we have someone writing a raw bash. I think this is a bash script here to generating the random angle, and then we connect it together. It works.
Okay.
It works.
That's how the demo shows up here.
Yeah. So, but this is about control. So let me disable the node for now and trying to enable the debug on the model node.
Okay.
So redeploy. Anyone volunteer goes in front of gimbal. Hi.
Frank? Can you show up your face?
Can you show up your face before this gimbal? Please. Oh, just a back. It works. Frank. It works. It works. Back. Please, just at this place.
Frank. We are calling you Frank.
Frank. So, yeah. Before now, Frank is standing or sitting. Hey, Frank, getting in front of this gimbal. And after someone gets
just standing right here.
Yeah, you can see after someone standing in front of the gimbal, you will see the model is outputting the target angle and target position of these people. And it will, as we haven't finished the PID tuning, so we haven't enabled this node here. So if we enable it, then the gimbal just turns too quickly and it will throw it up. But the logic is almost finished here. We will finish the tuning later. And If anyone is also interested in this project, you could check here. Well, this one hasn't been updated. This is the reCamera Gimbal open source project. So this repo has all the control script open source in here. And while the README hasn't been updated, the README will be updated about how we made it, what kind of technical architecture within behind. And we also will update the model on MakerWorld. This one was too early. This one was
3D printed.
Yeah, that was the first version. So you could see the one on my hand, this green version. That was the very first prototype, and yeah, we will update the newer, the latest model onto MakerWorld, and you could print.
Right.
Yeah. Okay. So. Yeah.
So these demos are like in the progress. We'll fully open source for all of the resources on GitHub, so you can take a reference how to design with our examples, right?
Yeah, and the robot arm, the industrial, and all these things. And someone had mentioned about thermal, night vision, screen baseboard. I think the night vision one, you should surely want that one. You want a screen baseboard attached for the night vision scope or maybe thermal scope. I think you surely want that one.
Okay.
That will also be a plan in the future.
Yeah, we also keep mind of that.
Yeah, and and after so many things, I think everyone is asking, what's the price, right?
Right, that's the most important part.
That's the most important part. So a good product doesn't comes with a good price, won't make it perfect, right?
Yeah, we won't keep it as a secret. So at the
today,
very last.
And here, so let's directly show you up. Okay, so for the whole unit, the first batch shipping with the standard cases and the camera sensor baseboard. There will be 4 choices coming from the 8 GB onboard storage to 64 GB, and it starts from $34.9. So no worry, your discount coupon could apply on the most expensive one.
Yeah.
So I think everyone get a coupon, and the winner will get the best one here.
Yeah.
And also, someone has been asking about whether the middle frame will come with. So that's also a problem. So I think a lot of people here is going to make their onboard or even test their onboard. Just need a song. So we are also going to publish the song for you. So here, where is it? Where is it? So we also have the song for you to choose. This song will come with the middle frame along with the core board to you, and it also has the 4 versions starting from $14.9.
Yeah, that's really competitive, right?
Yeah. Well, I think someone is also asking for the price of that gimbal. Okay, so the gimbal is now just an open source project, so I can't give you the price, but we could share you about the boom the boom of this how to purchase the the everything in the open source project, and we could build up some samples all together all around the world. And if more people want to have this kit to assembly, we will prepare it.
Okay.
Yep. Okay. So
these are like all the prices for the reCamera full system and for the SOM. So you can every coupon that we mentioned during today's live stream is suitable for the most expensive one, the full system reCamera 2002W 64 GB version. So you can also have the special offer to buy the 50% off coupon with only $5 to purchase the product, the reCamera that I mentioned before. So when it's launched, you can utilize this coupon code to buy it. So finally, I think we also want to call for everyone to join the alpha test. If
yeah.
you
That's also the place you could place the things you want, like you want a gimbal, you want a stereo board, you want something else, thermal or night vision. Just place in the alpha test registration, and no worry. Surely we can't. Not everyone will get the alpha test units. But everyone sign up for the alpha test will get an extra 10% coupon at last, no matter you got choice or not. So sign up for now.
Okay, yeah. So that's a lot of information today. We hope to deliver the most advanced AI camera for all electronic geekers. We're not so sure if we succeed, but right now you got the power to define how advanced it is. So for now, it's just early access version, and we are calling everyone join in to try on the reCamera first. Share your experience and ideas. We can build up this project with more expansions and solution possibilities, right?
Yeah, surely we want to build up open source hardware platform for camera. So as so many years has passed, there's still not a steady camera platform for everyone to design the software and the ecosystem upon it. We have the we have the ESP for IoT connectors. We have the Raspberry Pi for edge computing, but it seems that we are missing something in the middle. So that's why we come with the camera, and we want this standard. No matter what kind of core board you want to use, you could also contribute the new core board you want to design, no matter using the ESP, no matter using some other chip. So no matter, you could directly contribute into this ecosystem, but we hope every board could become compatible as much as possible. So this ecosystem could be reused once by once, again and again.
Yeah. So just contact us, contribute with our community, and stay tuned for our next amazing AI gadget. So we'll see you soon.
Yeah, I think that's all for today. So see you soon.
See you in the next gadget.
Stay tuned in community in Discord, or find me or find us on GitHub. Raise your issue, raise your request in the issue. That's also okay. Sign up for the alpha test. Don't forget that. And that's all for today. Thank you for coming. Thank you for
so
everyone.
Much.
And if I missed some questions, please send it later on Discord.
Yeah. Thank you.
Okay, see you soon.
Bye.
Bye.